Hello friends, in the previous three videos, we learned about the basics of Kubernetes. Now today in this video, let's try to set up a Kubernetes cluster on our local machine, on our laptop. So we will learn how to set up Kubernetes in our local computer. Okay. In the next video, we'll also learn how to do it on cloud or any popular cloud provider. So today for configuring it on our local machine, we need two or three things. Okay. First one, the self-sufficient thing is if we have Docker desktop installed on our machines. If we have Docker desktop, it is pretty much sufficient in itself. But if we use Docker desktop, we can only set up a cluster with one node. So if we want to set up a more production-like cluster, for example, if we want to set 3 nodes or 4 nodes, then Docker desktop is not sufficient. Then we need either K3D CLI tool or kind CLI tool. Okay, so we'll explore these two tools as well, and these two tools also need Docker desktop. So it is not like if you only install K3D or kind, it is sufficient. Docker desktop should be present. Along with that, if you have K3D and kind, then you can set up a multi-node cluster on your machine. Okay, so if you use Docker desktop, it is very easy and comfortable and convenient to use. It is great and easy, and using it we can set up a single node Kubernetes cluster on our local machine. And when you install Docker desktop, it will automatically install a very important tool which is called kubectl. Okay, so it will install, it is a CLI tool, and it will install this tool on your local machine. Okay, and it will also configure the kubectl context. What is kubectl context? So basically it is a collection of settings. What settings? First of all, the setting to identify which cluster should the kubectl be pointing. Suppose you have 2 or 3 clusters. So which current cluster you are using, to identify that setting is present in the kubectl context, and of course the credentials to access that cluster, that is also present in the kubectl context. So the context or the settings, whatever is there in kubectl, is saved in .kube with, this is a hidden folder. For example, if you use Maven, then there is .m2 folder. Similarly, for kubectl, there is a .kube folder. Inside that, there is a config file. So this is present there. Okay, so first of all, you need to install the Docker desktop application on your computer. For me, it is already installed. I will link the installation instructions in the description. But it is a pretty simple, straightforward step. You can download the binary for Mac or Windows, whatever operating system you're using, from the Docker website. And once you install the app, it is pretty much simple. You need to start the Docker desktop app. Here you can see that Docker is installed on my computer. And once I launch it, I can see that the Docker desktop app has started on my computer. There is a very important setting that we need to do. In order to do that, we need to click on the setting button. And then in Kubernetes, here we need to click on enable Kubernetes. And once we do that, then we can start using Kubernetes with the Docker desktop application. To make sure to enable this setting, so basically we will run kubectl get nodes command. It will get all the nodes present on this computer. For Windows machine, you can use the command prompt. I am using Mac OS, so I will use the terminal operation. So if we run this command kubectl, what do we get? We get a desktop node. We see its status is ready. What is its role? In node. If you don't know what is a control plane and what is a worker node, please watch our previous videos. And we can see that it was just created 6 minutes ago, and this is its version. So if you just use Docker desktop and kubectl, you can also on your machine, and the role will be a control plane. So since we have studied that generally we have one role planes and more number of worker nodes which actually do the processing, so we should configure a multi-node cluster for testing our applications. Even if it is local machine, we should configure a multi-node cluster. We will install K3D first. So we'll first try using K3D. it has node cluster. So basically it is a stripped down version of Kubernetes distribution inside Docker. And now let's use K3D to configure a real world Kubernetes cluster. Okay. So if you are using Mac OS, generally developers keep the brew package manager. So you can install K3D using brew install K3D command. If you are using Mundle to configure a package manager, so Chocolatey is also a package manager which works fine on Windows. So you can install Choco install K3D. So basically you need to have a package manager pre-installed on your machine to configure K3D app. Okay, so as I will use brew, you can use Choco. You can Google it out how to install Chocolatey on your machine. So let's install K3D. So what I will type, brew install K3D. It will search the internet for this tool, and if it is able to find it, it will install the tool on our machine. So you can see that it has, it creates its listing of all the apps. It updates the listing. Now you can see that it has started to download the binaries for this app. So it is downloading and doing some configurations. And now we can see, since there is no error, which means that our this command is successful. Brew install K3D. There was no error. Formulas, it updated many things. And after that, it is now installed. So in order to verify, we will type K3D minus version. And we can see that it is responding the version to us. So K3D is now successfully installed on our computer. So now we will create a 4-node cluster, and the name of 4-node. So this command 3D cluster create, and then we will give the name of the cluster. Then minus servers, we will give it 1. Using this minus, specifying that we want a single control plane node. Then we will give minus agents 3. So we are saying that we want 3 worker nodes. Okay. Then minus image rancher K3D lattice. So using this config Kubernetes to download this image from this registry and use this Docker image and deploy this Docker image on the cluster. Okay. So let's run this command and see what happens. So we will type K3D cluster create, then we cluster 4 node. Then we will specify how many nodes do we need. So we'll specify 1. Then we'll specify how many worker nodes we need. We'll specify 3. And then which image to deploy on all the nodes. So we will deploy on these nodes. So we use image rancher slash K3S and its version as latest. Sorry, I mistyped servers as server. So it will be servers. Once I hit it, it has created a network. Now it is trying to, so it is now trying to do other configuration, image volume. Then it is creating nodes. You can see it has created the first node. Then it has created the second node. Then the third node. Now it is also creating load balancer. In upcoming videos, we'll explain what is a load balancer and all these things to you. And now it is, trying to pull this image from the remote server. So this image, wherever it lives, it will try to pull that image from the server. So it is trying to pull this image as of now. So the processing has exceeded. So we can see pulling is successful now. And now it is doing some other configurations. So it is control pane. Then it is, so this is your pane. These are the identification. Also, if you don't know what is control pane, please watch our previous video. Then you can come back to this video. You will have a better understanding. Okay. So it is doing some other things as well. But as of now, you can focus on control pane and worker nodes. So I'm trying to create a 4-node cluster with 1 control pane and 3 worker nodes. So now let's check the clusters on our compute machine. We will have to try kubectl get nodes. Okay. So let's try this out and see what happens. So I will type kubectl that nodes. And now it has changed the context. That cluster is also still living, but the current pointing to is our newly created CD. Okay. So you see this one is the control pane. So you can see its role is also a control pane. Okay. And it has been created recently. And we can see that first of all this was created. After that all the three worker nodes are created. The role is showing empty here, but these are worker nodes. Okay, so three worker nodes that are getting created. So this is how we created a 4 node cluster using K3D. So apart from K3D, we can use another tool which is called Kind. So basically, it is a abbreviation of Kubernetes in Docker. We can also use this tool instead of K3D. So again, the prerequisites are Docker desktop app and kubectl. We have seen that they are already installed. Again, for macOS, the installation command will be brew install kind. As I already told, for Windows, you need to install the Chocolatey package manager. So the installation command will be choco install kind. Okay. So since we are using macOS for the demo, so we will run this brew install kind command. Let's see what happens. Okay. So I'm typing brew install kind. Again, it is looking for the kind application online. And then once it has found the application, it is downloading the binaries for this application. You can see it is saying fetching kind. This is the progress. It is downloading the app. We can see 100%. So since there are no errors, which means the installation is successful, we will check it by typing kind ---- virtual. Okay. If we hit this, we can see that it is showing us the version of kind installed, which means that our kind CLI tool is also installed. Okay. So now if you want to create a cluster using kind, we have to configure a YAML file. Okay. So this is, a more fine-grained configuration that we need to give. So say for example, we name the YAML file as kind.yaml. Okay. So this is the content of the YAML file. So first you will tell it that we are creating a cluster. So its kind will be cluster. Then you will tell the API version, which version of kind you want to use. So here we can see here that we are specifying v1 alpha version, and the specification of this version lives in this online location. Okay. Then again, as we gave the name of cluster in our previous demo, we'll give the name here. So what name we are giving? Cluster 4 node, and I am suffixing kind here to differentiate it from the previous cluster. Okay. So this is the name of our cluster. Then these are some networking configurations we learn in the future, but we need to give it here network. So there it will be a dual IP family. Now comes the specification of our nodes. Like we earlier created 1 control pan and 3 worker nodes, same thing we'll do here. So in the node section, first of all, we'll specify a role for control pane. Okay. And we will specify that download this Docker image and install it on the control pane. Okay. Then we will specify 3 worker nodes. So we are configuring the first worker node here. So role is worker. Again, we are specifying download this Docker image and install on this node. Again, on the another node, we are specifying again its role is worker. And this is the image that needs to be installed. Again, we are specifying the third role, which is worker. And this is the image that needs to be installed. In this way, we are specifying the YAML file. So these are the contents of the YAML file. Using this, so we need to create this YAML file to create a cluster using kind. So again, this is the content of the YAML file. We can see this is the name of our cluster. We have defined 1 control pane and we have defined 3 worker nodes. So all of them will install this kindest node version 126 from this remote location. Okay. So let's run this command now. So this file is present in our downloads folder. So we'll go there. We can see that this YAML file is present there. So we'll run this command kind create cluster ---- config, and we'll give it this YAML file kind.yml. Okay, so once we hit enter, we can see that it has started the processing. So we can see that it is downloading the images, then it is preparing the nodes, it is writing the configurations, it is starting the control plane now. Now it is joining the worker nodes to the control plane. Since there is no other, which this means that our cluster has been created. Okay. So what we can do is we can test it by typing kind get clusters. We can see that we get our cluster name. So this our new cluster has been created using kind now. What we can do more is we can type kind get clusters. What we can do more is we can type the command that we always type, kubectl get nodes. We can see that we get the new nodes created for this cluster. So this one is, the control plane kind of a node. So in its name, control plane is also appended, and below three are the worker nodes that we specified. So one is called worker, worker 2, worker 3. So these nodes has been created using kind. So friends, in today's video we saw how we can create a single node cluster using kubectl, a multi-node cluster using K3D, and a multi-node cluster using kind. So we'll further build upon this series and learn more and more about Kubernetes in depth. Wherever practical is required, I'll show you practical. Wherever theoretical is required, I'll show you theory as well. So keep watching this series. Make sure you watch all the videos from the starting so that your base is clear, and then you can develop on level by level increasing complexity. And don't forget to show your love by liking this video and subscribing to our channel, and please share this video more and more with your friends, colleagues on your social media, LinkedIn, Twitter, so that we get the expected views for which we put so much efforts. So I thank you a lot for watching this video. If you like this video, please take a screenshot of this video and post on your Twitter, tagging my Twitter handle SPS Tech in. You can find it in the video description. Please post a screenshot of this on your social media, whatever you want, maybe Twitter or Facebook or LinkedIn. You can find my social credentials in my channel, and please show your love, please show support to this channel. Thanks a lot for watching, and stay tuned for upcoming videos.